This is Dr. Sridhar, working in Institute of Aeronautical Engineering. Back to you with another video session on fundamentals of AC circuits and how the AC voltage or instantaneous voltage is generated and what are the requirements for AC voltage or instantaneous voltage generation. If a single wire conductor is moved or rotated within a stationary magnetic field, an EMF, that is electromotive force, is induced within the conductor due to the movement of the conductor through the magnetic flux. So if we could recollect the fundamentals of and what are the requirements for voltage generation, now mainly we require three things to generate or to induce the voltage in the circuit, in the electrical circuits. The minimum thing is, first we require a highly strengthened magnetic field or a sufficient magnetic field is required, and second point is nothing but we require one conducting system, and third thing is we have to develop a relative motion between magnetic field and conducting system. Then we can see some voltage, it will be induced in the conducting system. So the same logic here also we are using to generate or to see some instantaneous voltage. That voltage is nothing but induced voltage, which is also called as electromotive force, that we can see inside the conductor whenever the conductor is revolved in a stationary magnetic field. Or vice versa also we can do, if the conductor is stationary and if the magnetic field is revolved, then also we can see some induced EMF inside the conductor. These were invented 200 years before by Faraday's, and on his name, these laws or this induction of electrical voltage is known as electromagnetic induction. Electromagnetic induction means induction is nothing but there is no physical connection between any two fields. Now in this case, we are taking a conductor system and second one is the magnetic field. Of course, these two are not physically connected, even though we can see some voltage that will be induced inside the conductor. So coming back to the, what do you mean by electromagnetic induction? Induction is nothing but there is no physical connection, and electromagnetic. Electromagnetic means there are two different types of fields and placed one inside the other magnetic field, and if we could develop relative motion between electric field and magnetic field, then we can see some voltage induced inside the electrical conductor. That is nothing but electromagnetic induction. This was invented by famous well-known scientist 200 years before, that is Faraday's. So on his name only, this induction principle is known as Faraday's electromagnetic induction. So with the help of this Faraday's electromagnetic induction, we are going to convert mechanical energy, that is nothing but the rotation. Rotation is nothing but with respect to any reference axis, if the body is rotated by itself, then that is nothing but the mechanical rotation or revolutions. So this mechanical rotations can be converted into the electrical energy. So that electrical energy we are going to see in sinusoidal waveform. Now, if we want to elaborate how this mechanical energy is converted into the electrical energy, now we are going to take one simple electrical generator. Now with the help of that electrical generator, we are going to discuss about how that voltage is generated, and if the voltage is generated, and what are the precautions we had to take to see the voltage to be in the sinusoidal form. And before proceed to further that electrical generator, let us go back to the minimum requirements for electromagnetic induction. So in the electromagnetic induction, electrical system means a simple single turn, a fine graded electrical conductor, let us take. So like this we can develop conducting system. And next one is the magnetic field is also required. That highly strengthened magnetic field or sufficient magnetic field can be generated by keeping two permanent magnets, that is north and south poles. Then if the north and south poles are placed, then we can see some magnetic field between them. So like this we can generate magnetic field in the system and then conducting system. And the next thing is, if we have to develop some relative motion, means by keeping magnetic field as a stationary, if the conducting system is rotated in clockwise or anti-clockwise inside the magnetic field, we can see some induced EMF inside the conductor. So any conducting system, if it is rotated, we can see some electric current inside the conducting system, this is called as a electromagnetic induction. So this was invented by Faraday, and this is the fundamental principle for all electrical machines. And here the north and south poles were keeping aside to strengthen or to see sufficient magnetic field between them. Inside this magnetic field are represented with some green lines in this animation video, and this pink wire, or this is a pink line, represents the armature conductor. If the armature conductor, or if the conductor is moved up or down, we can see some induced EMF inside that particular conductor. Now like this, now instead of only one single conductor, if two conductors are placed, like one is a blue one and second one is nothing but it is a pink one, if these two are joined together to effective utilization of this magnetic field, let us keep two conductors, and if the two conductors are connected back to back, so automatically we can increase the voltage. Now the voltage induced in this pink conductor plus the voltage induced in this blue conductor added together, then automatically the voltage it will be doubled. To enhance or to see the voltage coming from this conductor, now we have to develop the physically this pink conductor is joined with the blue conductor in series to increase the voltage across this conducting system. So finally, this total square is nothing but this is a armature conducting system, or this is the electrical conducting system. If this electrical conducting system, like if the pink conductor is moved up and down, we have seen that there will be a induced EMF. Similarly, instead of one conductor, if you are going to place two conductors, and if the two conductors are connected in series, then what happens, how the voltage it will be induced, with the help of this animated video, let us discuss. And if the conducting system it is rotated, now automatically finally we can see a lot of induced EMF across these two terminals. And what will be the current direction? Now that is a very, very important here. Now in what direction it will be developed? So the current direction we can see are with the help of some right hand rule, Fleming's right hand rule. This is also called as a generator rule. Now this is a conducting system. Pink and the blue conductors are joined together. And for example, for a while, if that conductor is moved in the upper direction, then the blue conductor it will be moved in the downward direction. Now if the conducting system, if it rotates like this, now what is the direction of the current? We are going to assume what will be the direction of that current, and that will be illustrated with the help of Fleming's right hand rule. Now this Fleming's right hand rule is also called as generator rule. Now with the help of this generator rule, we are going to identify the direction of the current that will be induced in the conducting system or electrical conducting system. What will be the direction of the current that will be identified with the help of Fleming's right hand rule. Now just you arrange your right hand such that your thumb will be in the direction of the movement of the conducting system. In what direction the conducting system is moving, so in the direction you please align your thumb of right hand, and then your forefinger it will be in the direction of the magnetic field. So magnetic field in which direction that is there, now we had to arrange our forefinger in the direction of magnetic field, and then the resultant one is the current. The current direction it can be identified with the help of your middle finger. So coming to this one, now in this one the pink conductor, or this is the first conductor, it is moving in the upward direction. Then in such case, now you have to arrange so let us keep your right hand in the direction of the magnetic field, in the direction of the movement of this pink conductor, and in the direction of current, the current direction we can easily identify. So if the pink conductor is moving upwards, then our blue conductor is moving downwards. So you just align your right hand in the direction of the magnetic field and the conductor in which direction it is moving. Then our middle finger is going to give the current direction. So like this, if you could arrange our right hand, then this thumb is nothing but it indicates the direction of the armature conductor in which direction it is moving, and our forefinger is in the direction of magnetic field, and our middle finger indicates the current. So in the pink wire, in the pink conductor, we can see some current that will be inside the board, and whenever with respect to blue conductor, if you could see another side of this coil, then the current is nothing but it is towards us out of the boards. So in one single conductor, if you could see, now the current direction, it can be identified with the help of Fleming right hand rule. So if the conductor is moving upwards, like what it is happening in the pink conductor, now the current direction is into the screen. Now if the conductor is moving downwards, like what we can observe in this PPT, that if the conductor is carrying a current, or if the conductor is moving downwards, then that particular conductor carries the current out of the screen. So just for the sake of this, let us wipe these hands. Then what it is happening, now instead of these hands, instead of thumbs, everything, now we can replace that hands by keeping the direction of the current. So in this pink conductor, that current is moving into the screen, and in the blue conductor, current is moving out of the screen. Now these two conductors are connected in series. So the current is nothing but it makes a complete path. So the current is now throughout the conducting system, if you could mark the currents, and like this, if it is rotated, now in the clockwise direction, let us assume this total coil, if it is rotated, now let it rotate. Here also, now the direction of this currents, if you could see, now completely with respect to this direction, the current is changing. Initially, the current is into the screen. In the backward side, whenever the another side of the conductor, it is carrying the current in the upward direction. So alternatingly it is happening. The same conductor carries the current, and the direction of the current is also reversed if the conductor is rotated by 180 degrees. Now furtherly, let us check. Now see, whenever it is crossing this vertical axis, the direction of the current is also changed. So finally, we can say that the current is nothing but completely alternating in the nature. Now for 0 to 180 degrees, now if the total conducting system, if it is rotated by 180 degrees, we can see the pink conductor is carrying the current into the screen. Whenever it is rotated furtherly by 180 to 360 degrees, the same pink conductor, it is giving the current out of the screen. That is the beauty of this animated video. With the help of this animated video, we can see that the current in a one complete cycle, that is 0 to 360 degrees angle cycle, for a period of 0 to 180 degrees, any conductor, if it is carries the current in one direction, the same conductor, it has to change its current direction for another 180 degrees. So what now, if you could observe the complete cycle, so for 0 to 180 degrees, now the current direction is positive. It means the current is nothing but in one direction, and from 180 to 360 degrees, the current direction, it will be changed. So in one complete cycle, for a period of 180 degrees, the current is nothing but the positive. 180 to 360 degrees, the current is nothing but negative. So it means any conducting system, any armature conductor or any conductor, if it is revolved in the magnetic field, then the same conductor will allow the current in both the directions. Of course, for a certain period, it is in the positive. For the remaining period, that is in the negative. So alternatively, it is happening. Because of this, the output of this are across these two terminals. You can see the voltage. The voltage is nothing but or like a current. Now this is nothing but the alternating in the nature. With the help of this particular video, now we can see that the voltage is completely alternating in the nature. So 0 to 180 degrees, now the voltage may be positive. So it means the pink conductor may carry the current into the screen, and from E to A, so that is nothing but from 180 degrees to 360 degrees, the same conductor, now it will carry the current out of the screen. So for a certain period of time, it means this is nothing but it is one alteration. This is E to A, this is the another alteration. So this is a positive alteration. This is nothing but it is a negative alteration. So how much of time for this induced EMF E will take to complete one cycle? So one cycle is nothing but it is a set of one positive and immediately negative. How much of time it is taking? So that is nothing but it is called as a time period. And reciprocal of the time period is nothing but the frequency. The frequency can be defined as reciprocal of that is nothing but the 1 by capital T. So finally the voltage is nothing but that induced EMF, or this is the instantaneous voltage, in what fashion that induced EMF is there in the system, or in what fashion that induced EMF it will be generated across the two terminals of this conducting system, means in the sinusoidal fashion. So at 0 degrees the voltage is 0, and whenever it is moved to point C, means vertically upward direction, you can see maximum voltage it can be induced in the conducting system. Whenever you are traveling from point C to E, and at E again it will be aligned with the magnetic field, so that induced EMF is 0. Then again from E to G, if you could see that same voltage, but the current it will be reversed in the conducting system. But at point G it will have maximum amount of voltage, but in the reverse direction. From G to A it will be again in the decreasing manner, so increasing manner in the negative direction. So like this. So why this alternating voltage or instantaneous voltages or instantaneous currents or alternating currents are represented in the sinusoidal fashion means, so now whenever a conducting system, if it is placed inside the magnetic field, then you can see some induced EMF. That induced EMF will be in the sinusoidal fashion. So this is V of t is equal to V max into sine of omega t, or sine of omega t. Omega t is nothing but it is angular displacement. You can write it as a theta. So like this, a alternating voltage, we can say that alternating voltage is exactly in the sinusoidal form. So furtherly, for better understanding, now what are the parameters that induced EMF it will be influenced, and what parameters the induced EMF inside the conducting system it will be increased or decreased. So one is with what rate the conducting system is rotating inside the magnetic field. If the speed of rotation of this conducting system inside the magnetic field is high, automatically induced EMF will also be high. Second point is, what about the strength? What strength? Strength is nothing but the strength of the magnetic field. Now, if it is a highly strengthened magnetic field, so we can see that induced EMF will also increase in proportion to the strength of the magnetic field. And one more thing is length. The length is nothing but the length of conducting system. If the length of the conducting system, if it is high, then cutting of magnetic field will also increase. If more number of cuttings happens, then induced EMF will also increase. So here also we have clearly defined that what is the amplitude, what about the time axis, what about the off cycle, which one is positive, and if it is positive, how much of duration it is positive. So already we have discussed that positive off cycle, it will be there in the system from 0 to 180 degrees, and from 180 degrees to 360 degrees, now you can see that there will be a negative off cycle and it will be continued. And so if any wave is repeated by itself, then that is also called as a periodic wave, or that periodicity is nothing but the time period of the signal. If the voltage is represented with blue line and this is nothing but the with red line, we can represent the current, because we have assumed that load is nothing but the resistive. That is nothing but the load, if it is a bulb or resistive, then there is no phase difference between voltage and current. So these are overimposed on each other, but there will be a magnitude differences. Now if the current is starting at 0, so at the same instant voltage will also begin, and this will again come back to the 0 at the same instant. Again it will be penetrated in the negative direction, again it will come back to the 0, and everything it is happening at the same instant. At what instant the voltage is maximum, at the same instant current will also maximum, but there will be a difference in the magnitude differences, because this is happening because we have assumed that the load is nothing but the bulb. And there are some different periodic waveforms, but our simple generator will only gives the sinusoidal waveform. So we have given different instantaneous values and how many types of signals we can see in the electrical systems. Now sometimes based on our requirements, we can generate sine squared wave and pulse wave, square wave, sawtooth wave, half wave rectifier wave, and different waveforms based on our requirement we can see. Or even though if you are giving voltage, sinusoidal voltage across the inductor, either maybe current or voltage may be triangular one. So like this, it may happens across various passive elements. That's why one should have basic understanding, basic idea of different waveforms. And coming to this average value. So what about the average value? So we have already studied that instantaneous voltage is nothing but that is small v is equals V maximum into sin theta. What is that V maximum? V maximum is nothing but the maximum voltage of the waveform or instantaneous waveform into sin theta. Because all the alternating quantities or all the alternating current quantities were represented or were assumed in those signals are penetrated in the sinusoidal fashion. So any instantaneous voltage or any instantaneous current is nothing but the maximum voltage into sin of theta. That is the maximum voltage in the sense because we have taken instantaneous voltage, so maximum voltage. Instantaneous current, maximum current. Of course, it should be multiplied with the sin theta. So what is that instantaneous value? Instantaneous value is nothing but it is the value of an alternating waveform at any particular instant of time. So that if the time progresses, if the time varies, automatically the value of the wave is also varies. Such type of values are called as instantaneous values. And how can we define the average value? Average value is a constant value which produces the same amount of flux in case of voltage or same amount of charge in case of current as produced by alternating voltage or current when both are applied to the same circuit for the same period of time. So the average value is also defined as, in the mathematical expression also, we can define 0 to time period into V of t into dt. So this is 1 by whatever the time period. So like this also we can calculate the average value, and definition is nothing but it is the average of all the instantaneous values during one complete cycle. How can we calculate the average value? So here if you could see at t is equal to t1, the voltage is V1, at t is equal to t2, voltage is V2, so and so. At t is t12, the voltage is V12. So average value is nothing but all the instantaneous values of the signal. So how can we divide this time axis means at equally spaced mid ordinates. So we had to follow like this, otherwise just like that you are not supposed to divide the time axis. So for our understanding we have taken the positive of sine wave. So for a average value better you have to take only one half cycle only. So how many divisions you are performing, so that sum of instantaneous values divided by the number of divisions you have performed. Now if you could take the ratio, then we can directly get the average of the periodic waveform. And one more simplest formula is also given. F average is nothing but, or if the function F stands for the voltage, it might be voltage that is equal to 1 by t integration of 0 to t into f of t into dt. So like this we can compute the average value of the periodic waveform. Now one more is RMS value. This is very important, and this will be highly helpful for doing some practicals in the laboratory. This RMS value is nothing but it is a DC value equivalent to the alternating current values. So RMS value of an AC voltage is defined as that constant voltage which produce the same amount of heat energy as produced by the AC voltage when both are applied to the same circuit for the same period amount of time. So you take any conducting system, let us assume this is the conductor. Through this initially let us allow some DC current or DC energy, so you will get some heat energy inside it. So let us record that heat energy. After that, through the same conducting system, now let AC is allowed through this. And for what values of this AC, this heat energy is same. So that value of AC is nothing but RMS value of AC which is equal to the DC value. So this is the example, and like this we are going to equate a constant voltage. This is a constant voltage with respect to a AC voltage. So when these two heat energies are equal in the magnitude means, now it is happening at the RMS value of the AC voltage that will be equal to the constant voltage. So what is the formula for this RMS value? RMS value of AC or instantaneous values means, that is, so let us compare the AC power and DC power. So this is the AC power and this is the DC power. AC power has having different instantaneous values. Let the instantaneous currents are nothing but I1, I2, I3, I4 up to IN, because in the previous average value calculation also we have divided then one positive alteration into n equal parts. So at every instant of time, what is the value of that current? That is the I1. So I2, I3, I4, like this we have taken the currents. So these currents are nothing but instantaneous currents at different times. And next point is, whatever the power? Power is nothing but the I square into R. So at T is equal to T1, whatever the power, that is nothing but the I1 square into R1. So I1 square into R, because this conducting system, let us assume, having only constant resistance, you are not supposed to divide this resistance into different parts, because all these currents, all the instantaneous currents, these currents has to flow through this conducting system, where the conducting system resistance is R. This will be the same opposition created by the body to the incoming current. Of course, that incoming current has been divided into the different components or quantities. So the total current is nothing but the I1 square R plus I2 square R plus so and so IN square R, because the current by the first I1 is nothing but, power loss by the first quantity is I1 square R. Power loss at the second instantaneous time is nothing but I2 square R. Like this, power loss at nth instant is nothing but the IN square R divided by the total value is nothing but the N. So whatever the DC power is, generally DC values are represented with the capital letters. So P is equal to I square R. Then RMS value means the powers must be same. So let us equate this equation to this equation. Then we can get IRMS is nothing but the square root of I1 square plus I2 square plus so and so divided by the N. Or in the simplest form, FRMS is nothing but square root of 1 by T integration of 0 to T function square. So because the current function is nothing but, we have taken this is nothing but I of T over a time interval of T. Form factor and the peak factor. What is this form factor? Because now we have studied instantaneous values, RMS values and peak values, that is the maximum values. If one is known to us, we can predict the one other quantity also. So average value and RMS value and the peak value, with the help of these quantities, we can develop two more factors, that is nothing but the form factor. This form factor can be defined as the ratio between RMS to average, and peak factor or crest factor is defined as the ratio between the peak value to the RMS value. Now these factors will be highly helpful for us to know unknown parameter if one or two known parameters are available, but we can understand the importance of this form factor and the peak factor if you could solve one or two problems. Now these are the fundamentals and these are highly essential quantities. These are required for better understanding of the fundamentals of AC networks. Thank you for watching this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.